So it is a mono suspension system, right? So we can see 3 parts are there here. So I'm going to make sure that this can be replicated by patterns. I'm going to select all these 3 components and copying in the X direction here. Let's put a distance, generate, so that we can see one more. So let's put a little bit difference here so that I can see all 3 at a time. So there are 2. I'm going to add one more. Okay, now we can see 3 mono suspension system. Here in the first condition, so what I'm doing means, let's take a screenshot. In this one, in the condition number 1, I'm going to put a load on here. Okay, let's consider weight of the vehicle is 150 kgs. Okay, and load on here, I'm going to fix here so that I can see deformation. Similarly, same load is provided here, but there is a connection here. I'm going to provide connection number 1, and here connection number 2, and here connection number 3. Okay, in third one, in Ansys we have a spring elongation. So I'm going to remove this spring from the design. Then I will provide the elongation here. So I'm going to click on this one, right click, and going to suppress that particular component. Now minimize it. Go to Transient Structural Analysis, drag it and leave it over here. Click on the model, right click, then edit. Now, okay, on the left side we can see connections. In that one, predefined connections are there. This one belongs to here, so I'm going to keep these connections as usual, but I'm going to remove all this rest of the connections here. Delete. Okay. Now go to the connection, select body to body connection. In that one, I'm going to select fixed. Now go to the display, click on export factor, increase the scale factor. So in this one, I need to fix this face to this face. Apply. Repeat the process, bottom also. Again, connection, body to body fix, select this face and this face. Done. One more connection I'm going to add. Translation, selecting this cylindrical face and selecting this inside cylindrical face. The second scope. The same connection I'm going to repeat for this one also. Select cylindrical face. Sorry. Click on translate. Selecting these cylindrical faces and selecting these cylindrical faces. Okay. Now for spring connection, I'm going to click on body to body. Here. So click on joint, right click, insert, you can see spring. Now choose this face in one scope and choose this face in another scope. Okay, now change the values as required. So let's put stiffness is 10 and damping effect is 10. If you want to decrease or change, you can change. For example, 0.1 I'm going to specify. You can see differences here, but I'm not going to do that. I'm going to specify only spring connections here. You can specify spring. Let's put this one as 10 and followed by 10. Okay, once it is done, now I need to apply loads here. I click on the transient, select fixed support for all the suspensions. For here, one more, here, one more, here also. I'm going to select all these bottom faces are fixed point. Now I'm going to apply forces. Before going to forces, click on the analysis settings, then specify initial, maximum and a minimum time steps here. Now I'm going to click on transient. Inside, I'm going to click on force apply on this face. This one should be downward direction. Here I'm going to specify easy. So downward direction vector to component z direction is equal to minus 150 kgs into 9.81 newtons. Same thing you have to repeat. So duplicate the force, select the second force, select the second face here and apply here. Select force, choose the face, apply here. Now, as a result, I want to see deformation, stresses and strain, right? So I'm going to click on solution. I want to see deformation, I want to see stresses, I want to see strain. Then choose a side. So here I'm going to choose this edge. This edge is given as 4 mm. So here I'm going to specify mesh size as 2. Then click on solve. Click on deformation so that we can see a deformation. Simply select the edge to no wireframe so that we can see only true colors of the analysis. Now, here right click on this solution, insert, and followed by select the problematic, choose the spring so that we can see how much load acting on the spring. On the spring, we can see it is around damping effect will be 978 newtons are applying here. Okay. Let's do that. So I'm going to click on total deformation. We can see the difference in the application. Let's compare all these three. I'm going to click on total deformation. Here I'm going to select only edge, selecting this line and apply over here. Repeat the process for this one. Again, repeat the process for third body. Then select the total deformation, convert to path results. Convert to path result again. Convert to path results. Evaluate all results so that we can see deformation of individuals like this. Now I'm going to click on this tree. I'm selecting chart here. So now we can see maximum minimum deformation causing on the body. So this is a minimum and this is a maximum. Or we can simply go to deformation, select deformation, only select these bodies. By using contact, deformation by using connection, deformation by using spring. I can see this deformation is around 0.00508. For this one it is coming around 3. So around 4 it is coming. For this one we are getting around 5. So there is a huge difference between deformations. And also if you want to see stresses, select only these bodies. One stress, connection stresses, and followed by spring stresses. And evaluate results so that we can see difference in the stresses also. Here we are getting around 13.4. Here we are getting around 894, which is huge. So that means the spring is going to deform more. And here we are getting 13. The main difference is here the connections are given. Here the connections is not given. And here only sliding distance is given. If I click on total deformation, click on play button, we can see the results, how it is going to form. Click on second total deformation. See, the spring is going to compress here. That is the difference between connections and contacts. If I select the third one, we can see difference here also.